Thank you, Harold. So, yeah, this talk, I'm not really inventing anything. I just did something at work that I hadn't done forever or in a very long time. So I just thought this was interesting. I'm sure someone else might find it interesting too. So Ghidra saves the day. I think my first slide is about my professional history, just so some reasons why you really need to take me very seriously. So I worked on a lot of games, and at least one of these I worked with some people in the audience on, and some sound software kind of on the side. Currently I'm working on another game that just opened up for playtest. So if there are any epic gamers in the audience, you should go to Bonfire Studios and sign up for playtest. It's pretty good. We playtest it every day. Okay, so this is a C++ meetup. This talk isn't really about C++ specifically at all, but if you know a lot of C++, or if you use C++, maybe you like things that are compiled at least, and we will look at compiled code and basically see how we can change it. And it's easier now than it was 10 years ago or 15 years ago. I first saw someone patch code that was compiled in my childhood, back in the Amiga days, when a friend of mine had a game that wasn't cracked or anything, and he just hit a button on a cartridge and was able to inspect all the memory, just switch one location, one instruction from a equals to not equals, then answered back in the day you had like manuals that you had to look up answers in, and that was like the copy protection. And I was pretty impressed back then, and it always seemed like something cool and like semi-forbidden to do. And I had never had a real need to do it until now. So the reason why this thing unfolded in the first place was that the game I'm working on now, a bunch of stuff in it opens up ports, listens to ports, basically acts as a server, and when you start it, you get this scary pop-up, and we didn't want our poor customers or poor players to be scared away and say, wait a minute, what are you doing? And it's expected in development builds, because we actually do open up a lot of ports and listen to all sorts of tools. A lot of third-party things do the same. When you make a game, you have a bunch of third-party things, and they all have tools that can connect to their runtime. That's the reason why that was my kind of task, or that's why what I started looking at. So my task, so to speak, was to find all the usage of listen, or find all the usage where we act as a server, and try to remove them. I talked to a dear colleague of mine that actually had a blog post with a bunch of debugging tools that he has used in his days. So I'll just include his blog post there. And the first tool that he suggested, I've tried a few tools to find all the places, or to inspect the game, the title as it was running, to find every time we act as a server. Some didn't work very well, but one that did work is called API Monitor, and it's pretty useful, and that's going to be the first thing I'll just show some screenshots of. API Monitor works as, you could say, like a man-in-the-middle attack between your game and basically all the Windows DLLs, or you might have different tools on Mac, maybe you don't, but this is all on Windows. And it will basically log every call to every system functions, and the parameters and the return values, and it will just list them all. And it will be very big. If you have a big game, you're going to have millions of entries. The good thing is, and basically the only thing I'll show here, the trick is that you can actually filter out stuff. And in our case, we only needed to look at networking calls. So I only cared about those and filter them out. And this is kind of what it looks like. You have a bunch of executables in the top left corner, On the right, you have basically every call. And this way, it's pretty straightforward to find what DLL or what module that is making the call. You can see the port number, so sometimes it's easier just, you can see a port and you search like, wait a minute, who defines this port? And you'll find it in the code somewhere, and you'll figure out how to patch it out, or like change the code basically, or do a if release, something like that. And this is pretty straightforward if it's our code. And yeah, I don't know if it's very visible, but it says game assembly.dll, and that's basically all your code. If you write game in Unity, most of your code will be in game assembly.dll. And what happened, or what I noticed, was that at least one third-party DLL that we didn't have source access to was also doing this, basically opening up ports and listening to it. And we couldn't find any options or any way to ask it not to, because we didn't really know what it was doing or what it was trying to do. Yeah, so I didn't really know what it was listening to, but my suspicion at the time, at least, was that it had to do with peer-to-peer voice chat, because that was like at the time in the playthrough when you were playing the game. That was kind of when it happened. And another good thing here is that the scary pop-up, if you actually say cancel, don't allow this thing to listen to ports, the game would still work, the voice chat would work, everything would still work. So luckily, it wasn't a critical path. So hopefully we should be able to just find that call and remove it. And so this is, you don't really have to read all of those pieces, but you can basically, in Ghidra is the tool. I will have a super tiny kind of demo time later. Ghidra is the tool that can disassemble, decompile, patch, and patch basically the executables. So you import it, you analyze it, you click through a bunch of forms, and then you will find something like this: a program tree, a symbol tree, a list view they call it, and then you have a decompiler view as well, not visible here. But you can here in the symbol tree you can look for a specific function. In our case, listen. You will find the pointer to an external function, as it's called here, and luckily you also see the thing called xref there on the right, which is basically all the references to this external pointer in the whole DLL, at least, because yeah, that's what we're opening. And luckily there's only 4 places where that call to listen, so we should be able to just try disabling them one at a time to find our listen call. Yeah, but just following one of those xref, you'll see a function that looks something like this. If you look at something that's compiled with in debug mode, you will actually get like the right symbols and everything. It will be much easier if you have like a PDB file or something. This is optimized, so it doesn't look very good. It's, you see, fun underscore and then just the address. So like the names of stuff isn't amazing. So in Ghidra, you can just right-click on the line you want to change and do patch instruction. As you imagine, this talk will be pretty short because I'm just saying this is how you do it. But we'll see. That's why I added in the little demo at the end. Yeah, to do this, you need an assembler, and Ghidra have it all. Everything is built in, but sometimes it just keeps initializing stuff as it needs it. So you'll end up with basically the red squares there. It's like you can just type something else in it, hit enter, and that's the end of it. But the question is, what do we do instead of calling that function? So it doesn't really say, but that function is yeah, here you see it. It says DLL listen, and here it says just the address of it. What do we put instead of it? So what the easiest way to replace this call, in my mind at least, there are multiple ways of getting to the same result, is to just move the error code into the return register. So if listen fails, it returns a socket error, which is -1. So if we replace the call to listen to just move -1 into the return register, that should be it. Yes. So it's as easy as move -1, or that's how you type -1, unfortunately, in this place. And yeah, you see there kind of like a drop down that comes up with different versions of the move instruction. So many instructions. I don't even want to go into deep. You have so many versions of move, so many versions of most instructions. It depends on how much of immediate data you have, what register it ends up in, and so on. So these two are the C7. The two ones are for 32 bits or 64 bits destination register, I think. Doesn't really matter. So you'll also see that this instruction is the same length as the call instruction. It's all 6 bytes, which is lucky, because if it's not, it's not going to be that easy at all. So that's kind of what you want to find as well, patching things that are from one thing to another that doesn't become much longer. If it's shorter, maybe you can insert something else in between. So that's basically the difference before and after. Instead of calling the function, you just move -1 into to the register. And you can see the test EAX is basically, well, now we didn't look at the decompilation thing, but this basically if 0 is what it does. After you patch it, you just do export program, make sure the format is original file, which is, otherwise there's some Ghidra specific formats. So that's the shortest version of this ever. Unfortunately, the first place I did patched up actually did break functionality. So that's the danger of this. Is kind of like rolling the dice, right? Oh, I found something, I'm gonna take it out. Kind of had to test to see if it works. And there were 4 calls. One of them was the right one, and you test it a little bit, you ask QA to test it more, and then you feel like, okay, that's probably it. One thing to notice is also that in this case, just a few bytes in the middle of a huge file changed, and it would be pretty easy to slip this thing in as kind of to switch it out for unless you sign executables and DLLs, it's really hard to know what they're doing or if they're the right thing. Basically, like they could look very similar, and they could definitely be patched. And yeah, so a lot of that's basically what most game consoles don't allow you to run unsigned code, and that's basically the remedy if you don't want to run patched things. Okay, let's do a super quick demo of this. I have a super short example here of in our imagination, we can imagine we're a streamer and we want to play a game and we want to have an easier time than other people playing the game. This was like a scandal for some Minecraft streamer or someone. So this is a super dumbed down example, obviously, where actually this is not the code I was trying to run. It's good enough. So imagine we have something random or something that depends on something. You get a rare coin or you get a common coin, and we can imagine that we want to change it so that it becomes more common for us to get the rare items. So that's what I've seen people do. So if we just compile that and run it, oh, I get common coins all the time. Poor me. Okay, so now I'm going to start Ghidra here, and launch the simple tool. Actually, in my little presentation, I had a thing where you could imagine, so if we want to get better probabilities, you could imagine setting this R value to something, like don't do anything random, just set it to 0, so this you always get a rare coin. You could imagine finding this constant, the 4 constant, and set it to wherever you want. Like if you just wanted to get twice as often as someone else, you just find the 4 and change it to an 8. You could change this switch to be like greater than or less than. So I think in my case now, I'll just change the 4 to something else. That sounds like an easy way. So this is the code browser. We're gonna load our program. And here you see the decompile. It's pretty useful. So we call our get tick count, and then we do some math on it, and we either get a rare coin or we get a common coin. So in this case, we see the 3 or less than 4 there. We can just right-click, patch instruction. Constructing assembler. This is what I'm talking about. I had to throw in this live demo to pad out the time so you guys don't get bored or don't get to eat too fast. So we can do this. We'll do something high just so that it will always give us a rare thing. I just changed the number. Export program. We'll call it A2 instead. Oh, this is the joy of having too small of a screen. And what? Did I get a common thing again? What is going on? Did I not click? It's funny how that's amazing. I wonder if I have to hit OK on that thing or not.
What are you pressing?
Good thinking. This is why they pay you the big bucks. Well, that was probably the least interesting thing I've ever seen. Oh, wait a minute. If it's less than that, I get a common coin. Okay, that's odd. Oh, JB. Okay, let's try the other. Let's try to patch this other thing. And did I not save it correctly? Okay, now I get rare coins all the time. Lucky me. So, very. That was worse for me than it was for you, I think. Okay, I think that was my last slide. And any questions or answers? I might have an answer. Yes, Arvid.
I would expect the dialogue for Windows to be scarier if you're trying to run unsigned programs than if you're trying to listen to a socket.
Yes. Somehow, we don't get that warning, and I don't know if that's, I don't know why.
If Windows tracks in the file system, if you download a file, it marks it as from the internet, and then it checks it.
Yeah, so either it's because it's from a trusted source, or honestly, a lot of our QA department didn't get this warning pop up either. It's a setting in Windows, and it depends on if you're Windows 10 or 11, or if you have like an organization managing your settings, basically, like the QA department had. They couldn't change it, but they didn't get it. Next question.
For which architecture and operating system it's available?
Sorry?
For which architecture and operating system it's available?
Ghidra? Short answer, I don't know. I only know that it's available for Windows for sure. It's probably for all, because Ghidra is developed by NSA. That's why I really trust it to install it on my computer. And it's written in Java, so installation is a little bit awkward, to say the least. But I'm pretty sure it's available, definitely on Unixes. Yes?
Did you run into any legal issues about distributing a patch with quality?
Yes. Well, not really legal, more like a relationship with the people who we get, the vendor, or the people we get the DLL from. So this may or may not actually ship. Like I don't know how it will end up, but at least we showed them that, well, we don't need this thing. Can you please turn it off? And they were like, well, I don't know where it is either. And hopefully we'll ask them more in the future. But yeah, no, that's the problem. Like, just because you can change DLL doesn't mean that you're supposed to, or the person who gave you the DLL actually wants it. And yeah.
Why did the first edit didn't work? I didn't understand what was the problem.
Here, oh, in my little live demo?
Yeah.
Good question. I don't. I don't. It could be that the immediate data type was very small. It might have been no.
I think it wasn't saved the first time.
Yeah, maybe I needed to like do Control S or save or something like that. Yeah, I actually don't. First, I rarely use a laptop, so that's my first handicap. The second one is that the screen resolution is become very small because it's on the projector. So I'm extra not used to it. Any other thoughts? Yes.
You mentioned the replacement command had to be the same size. Can you, if the replacement is smaller, can you add, or is there a workaround if the replacement is longer?
Good question.
If it's smaller, you add some not instructions. If it's longer, you find some empty space somewhere out there.
Yeah, you can probably do it. I haven't figured out how to do it. I haven't looked for it, because luckily that worked. And again, this is not my main job. I just thought it was interesting that it worked. Yeah. Any more? Oh, thanks.